Hello, everyone, and welcome to our new season of New Breakpoint. My name is Michelle Sanford, and I am the Developer Engagement Lead for Microsoft in Australia and New Zealand. If you are joining us for the first time, then welcome. This show is broadcast on the second Thursday of every month. If you register for it and miss it, do not worry. You will be able to watch that on demand. We will do Q&A during each broadcast, so you can talk to me and my guest during the session. Just put your questions in chat and we will answer them. We'll also hang around for about 10 or 15 minutes at the end of each episode to finish off any questions we haven't gotten to. If you're wondering what New Breakpoint is, it is a show for developers by developers, and we have a extraordinary lineup of fantastic, deep technical guests who will share their expertise with us in each show. Today, I am really excited to introduce April Edwards. April is the DevOps practice lead and a developer advocate at GitHub. She was part of Donovan Brown's League of Extraordinary Advocates when she was at Microsoft. And she does Ironman, she does marathons, and she's a scuba diver, so she could pop up anywhere in the world. Welcome to the show, April.
Thank you, Michelle, for having me. Really excited to be here.
What are you going to be talking to us about today?
Well, in true form, I'm going to talk about DevOps because we always talk about DevOps and DevOps practices. But more importantly, we're going to talk about DevOps on GitHub. And I think we want to talk about some of the cool new features at GitHub because when GitHub started, it was really just source control and a code repository, right? So we're going to go through some of the really cool features that helps developers embrace DevOps practices and the DevOps cycle. So what is DevOps? I mean, Michelle, if I were to ask you what is DevOps and every developer out there, we would all have a unique answer because we have different life experiences, different backgrounds. So we like to level set into what DevOps is. So we like to define DevOps as the union of people, process, and technologies or products that deliver continuous value to our end users. And that value is critical because we need to align our teams to make sure we're delivering the same thing to our customers. Because if you think about it, Michelle, like as a developer, you're writing code and you're incentivized to deploy more features continuously, whether you're in a 2-week development cycle, 1 week, and some development teams are much longer cycles, but they're incentivized to deliver that code. Whereas the infrastructure teams or those operational teams are very much focused on keeping the lights on 24/7. And those two things often conflict. And I also work with a lot of teams that talk about security, their PMs, and the other parts of their organizations. And they go, when do we bring these people into the conversation? And I always tell them from day one. So we want to make sure that entire team is delivering the exact same value to our end users, which is usually our customers, or in this case at GitHub, you, the developer.
That's awesome. I always think of it as the point where they started, the point where organizations started bringing teams together so that they would talk to each other. And when I mean teams, I mean other teams, so that, everyone talked to each other, whereas before no one ever talked to each other.
No, we always worked in silos, right? So DevOps is absolutely about bringing down those silos and doing something we call shifting left. And I like to call it doing things early and often.
I was going to ask you about that because I think when I saw shifting left originally, I thought, oh, great. So that means I have to do everything. I have to do the security. I have to do the code. I have to do the testing. What are all these other people doing if I have to do all of that? Is that what it means?
Well, not just you, but it does mean we do things earlier and more frequently in the process. So let me give you an example. So Michelle, what's one of your favorite things to consume, do, or eat?
Thai food.
Thai food. Okay. So where you live, is there a Thai restaurant that delivers to your door, or maybe a service like Uber Eats, DoorDash, etc.? So if you think of those organizations, those are high-performing DevOps organizations because they've come to you as the consumer and delivered that value, which is really important. But the way they've done it is they've engaged their teams to do everything early and often. So does it mean that you have to do it all? No, but it means as a team, you start considering these things earlier on. So if you think of a delivery company that might be delivering food to your house, like Uber Eats, if they had a breach in their data, do you do you feel that they're providing you with a value, or are you going to lose trust in that organization to deliver your Thai food?
Well, that's a really tough one because I know they have had a couple of breaches and I should have lost trust in them. But I do really like the service they deliver to me.
And that's a tough one, right? And I know exactly which organization you're talking about, right? It's Uber. Uber has had several breaches. And ironically, they've had the breach for the same reason. They've put a password in a plain text file where anyone could access it, which is not smart. So I always tell people, don't put passwords in plain text files. But you and I both work in the cloud, and actually 96% of cloud breaches occur due to human error. So when we talk about doing these things early and often, it's cheaper for an organization to implement these practices in the developer cycle versus production. So that breach in Uber has cost them millions and millions of dollars, or pounds, euros, or depending on your currency, but dollars, right? But it's hard as a consumer to say, oh, I want to go back and use them. We need to make sure that they're using safe business practices. So in other organizations that are a little bit more maybe financial related or health industry related, those implications for having breaches is a lot higher. So when we talk about shifting left, it's about bringing the practices that not things are an afterthought, but they're a forethought as we start writing our code.
I have noticed that about GitHub these days. When I first started using it, I did have secrets in my code. I did used to always, and I know I'm not the only one that did that, but these days it's a lot harder to do that because GitHub helps me. It picks all those things up.
Absolutely. And I think we have to think of security, like we all have to think of security. And I'll be honest, as a developer, when I started shifting left a lot more, that included security. Because if you've worked in the cloud, you know that when you started shifting to the cloud, deploying code into that cloud, the security team was always the one that said, you can't do this. It's not secure enough. You're not compliant, etc. So it's about building that compliance in a lot sooner. But as a developer, like I don't love dealing with security practices at all. So and I put passwords in my code. I'll admit it. I've done it. So what we've done is we've brought the tooling closer to the developer experience, because we know as soon as developers clone their code, that's when security actually begins. And that fits into that shifting left mindset. So we need to prevent our developers from doing silly things, but we don't want to control them. We want to enable our developers to do more. So putting these security overheads can be a bit cumbersome and a little bit tough, especially when we're trying to deploy to the cloud or other environments. So you see a lot in GitHub where we're bringing the tools closer to the developer experience, and we're doing that specifically to take the burden off the developer. So you and I can, maybe we shouldn't put that password in our plain text file, but if we do, we can discover it and eradicate it before it goes to production. Does that make sense?
Yeah. Is that something you want to show them? Do you want to just show them in the settings where all of those things can be turned on? Because there are so many things in there to do with security. I was just going through them the other day, and I just think this is amazing that that's all there, just basically in GitHub, in your, like, not even something that you're paying extra for, just in your free repos, you have a bunch of stuff available to keep you safe.
Yes. So that's something that's been really cool. So we'll head over to my screen here, and I'm just going to go really simply. This is a repository with a bunch of code. It's doing different stuff, but I want to go into the security tab. Now, we've purposefully planted some security flaws in there. So for anyone that's looking at this going, we all make mistakes. It's okay. So in the security overview, literally with a click of a button, we can enable various types of security in our repositories. There's some free options, but then there's also some paid for options. But this is all part of the GitHub Advanced Security package that's included in GitHub. So the first thing I want to talk about is Dependabot. Now, when we're writing code, we are often consuming packages. And how do you maintain your packages in your code, Michelle? Exactly. Like I know where you're going with this, right? I don't. And it's hard and it's time consuming. So I've enabled Dependabot, and Dependabot will literally scan my repository for those dependencies. When it does that, it will go ahead and give them a tag. So it's put these at a high alert, it's put some others at moderate alert, and some here at low alert. So if I click on one with a high alert, it's picked this up, and it can see what versions in my code I'm using of this package. It tells me what patch version I need to go to at minimum, and it gives me some impact. It gives me some sample code. How do we resolve it? And then how to deploy it and fix it. So it's opened this up. It's told me how to fix it and resolve it. Makes my life much, much easier as a developer. The other thing we can do is sometimes we do things in our code that we shouldn't, but maybe we, have already started a fix. We might not have any bandwidth. But more importantly, not only has it told us this, it's opened what's called a GitHub issue. So it's open an issue in our code base. It goes straight into our backlog. We can then put it into our developer cycle. So it's already highlighted the dependencies we have in our code. It's give us some tags. And these are things we could very much easily remediate on our own. And we can see some of these already have a pull request associated to them. And what it's done in this instance is it's given it a pull request with a fix. So we can actually review the security update and we can see the pull request here, and it's provided us with a resolution. So it gives us release notes and a change log. So we need to trace the changes that we've made in our code. And then very simply, once it goes through all the checks in our organization, we can go ahead and merge that pull request. So that's pretty cool. So that's dependencies. So what do you think of Dependabot so far?
Oh, I love that.
Now, let's go to things we've done in our code, like, I don't know, putting secrets in our code. So we've purposely put in a couple API keys here. So with secret scanning, again, it's very simple enablement with the touch of a button. It scans for any secrets in our code that are potentially exposed. So this could be connection strings, secrets, Azure login details, et cetera, et cetera. In this case, we used a Google API key, again, purposefully planted for this demo. And it will give us some remediation. We want to rotate our secrets. We want to revoke it, et cetera. And it tells us exactly where that is in our code. We know exactly what file it's sitting in, and we can go ahead and remediate it pretty quickly. Now, the other cool thing about this is, we can prevent this. Now, this has already gone into our code base. The secret scanning has already scanned our code base for this change. We also have something called GitHub push protection. So as we're writing our code as a developer, and we might accidentally put that secret into our code base and then create that pull request, push protection will stop the push of our code until it is remediated. So this is, again, bringing those developer tools even closer to that developer experience. The next part I want to show you is code scanning. So this uses something called CodeQL. When CodeQL gets initiated, I'm just going to go ahead and show it to you here. As soon as we turn it on, it gives us a code scanning workflow. It automates the code scanning. So if I go to the workflow that it generates, we can change it, but out of the box, it gives you on push or maybe build of your branches, or in this case, a pull request against our main branch. And it's going to go ahead and set up some code scanning. It's going to check out our code, and it already sees that we have Java in our code base. So it's going to go ahead and scan the Java code, initialize that scanning, and CodeQL treats our code as data. But again, to do this analysis, we already have to have it in our code base. So here you can see that we've ran this a few times. If I click on this, I can see that it's ran. I can look at all the steps of it and know what it's done to check out our code. I make this code scanning part of every single pull request in my organization, just so that I can make sure I don't have any issues. So what happens when something does actually get through? So we have some critical vulnerabilities here, which are always fun. Let's go ahead and click on one of those. Now in this, it will tell you where the file is located. Again, you can create an issue here. So we can create an issue in our GitHub code base to fix this alert. We can assign it to someone, so I can assign it to myself, and we could give it a label. Maybe it's a bug or some other issue. And very simply, we have it tracked on our backlog for us as well. So, and again, it tells us we can link it back to the original alert. So there's full traceability end to end of that alert. So if I go back to that alert, it tells me more about it. And it gives me versionings, et cetera. And it gives me the CVE link to reference. Because again, this is documentation that as a developer, I would not have any idea how to get this. I don't know if you would.
It would take me a long time to do it, and I'd probably get distracted with the context switching of looking things up and all of that. So yeah, this is a huge, huge time saver, and it means I'm less likely to ignore the vulnerability as well, because I don't have time to fix it.
And we have full traceability, so I can go back here and look at the issue that it created for me. Again, full end-to-end tracking of what we're doing. So you just mentioned something very interesting. You just talked about context switching. So part of the developer experience is about context switching. So if you look at the average life of a developer, like your day-to-day, not the whole life, your day-to-day of your job, how many hours a day are you writing code, Michelle?
Yeah, I guess it
Not
depends on
enough.
the
Not enough,
depends on
right?
the day. Yeah,
I
not
feel it.
not enough for sure. If I can have real pure focus time and just be in it, then yeah, that would be amazing. But that is not what my day looks like.
No, and I agree with you. I mean, I started writing code to have fun and to play and to do all sorts of amazing things. However, the reality is I'm waiting on others. I am waiting for compute. I'm waiting for access to things. So let's talk about context switching here because this is one of my favorites. And this does play back into the security piece a little bit as well. So this is our code base. This deploys a bookstore app into Azure for us. Has a bunch of different code in it, does some cool things. Has different packages in it, as we saw. So it's a good all-around app to kind of play with. Now, when you go to get started in a new repository, Michelle, what's the first thing you do?
The README, I guess.
Absolutely. Go to the README. So we need to look at what's happening, but also we need to clone our code and install our dependencies, correct?
Oh yeah, I am using code spaces almost exclusively these days because I have made such a mess of my machine so many times by all of that and yeah, on code spaces you will get exactly the things that you need in that repository. So yeah, am I stealing what you were going to say?
No, I think that's perfect. I mean, and not only that, I have multiple devices. So I've got a Windows machine in front of me. I've got a Mac on the other side of me over here. I can code between the two machines interchangeably. So normally we would go ahead to the code button here. We'd clone our code, do all of our dependencies, get started, and it would take a lot of time. However, if we go to this code spaces button here, we can add a code space. Now I want to show you the different types of ways we can create a code space and how this works. So we can do a new one with options, which we're going to do. We can configure a dev container, and I'm going to let everyone in on the secret of what the dev container is and what makes code spaces so special. And then for really large code bases, we can set up pre-builds. So when you have code bases with a ton of dependencies and prereqs to get installed, you set up a pre-build, and from a code base that might take several minutes to spin up. This will take, when I say several minutes, I'm talking 5, 6, 7 minutes. It will get it down to less than a minute. So the pre-build's even faster. We can also manage any code spaces we spin up, and we can share deep link. But even better, what are code spaces and all the code spaces documentation? That's really important for people. How do you get there? So instead of worrying about getting my code ready and everything else, I'm going to create this code space now. While that is creating, I just want to show you what new with options looks like under GitHub code space. So I am creating this code space off of my main working branch, and it asked me for the dev container configuration. And this one just has a default, and I'll show you what that looks like in a minute. But importantly, region. So you're in Australia, Michelle. You're going to want to spin one up in Australia. I'm here in the UK, so Europe West works for me. But more importantly, machine type. Now, with this code base, we know that we cannot run on 2 cores and 8 gigs of RAM because it's just not enough compute. And we want to limit what our users are spending, so we max them out at 16 cores and 64 gigs of RAM. But I'm going to take the lowest option because I can scale my code space up. So often as a developer, we're often using a machine that might not be able to handle the code requirements or run tests locally. And I've been in that situation many times where my machines just crashed, where it's run out of compute. So here I can go to the lowest common requirement and I can scale this up, which is really important. Now, this code space sits in the cloud. It spins up a virtual machine. It's a containerized environment in which we run our code. So why is this important? Because if security starts when our developers clone their code, we have to secure our developers' devices. That means a lot of customers don't have admin access to their own machines. They can't install stuff. Remember, we have to install those packages. That takes a while. We give every developer the same tools they need to do their job. Now, again, Macs versus PCs, testing tools, etc. We can ensure that we have a more secure code base and a more secure development environment when we secure those tools. So how does this magic happen? I'm going to go to this dev container folder here, and we have a dev container.json file. Now, by default, when you spin up a GitHub code space, you get the default build, and that will give you things like .NET configuration, et cetera, et cetera. You can run various languages from it, but it doesn't do everything. So in this code space, we call a Docker compose file here, and that will tell how to build a container. That basically tells what image to build a container on. And again, if this is a Java-based image, you could do an Ubuntu-based image. You could do any kind of flavor, maybe for the language you're working with. And that's how we call that file. And then things like port forwarding. So often I work in cloud native environments or with websites, and we need to forward ports, so we can declare that there. We can also open up the SSH port, which we've done here, and we've put labels against them. And what's even cooler is we can customize the the Visual Studio Code extension. So you're working in a GitHub code space. It looks identical to Visual Studio Code. So I actually have my settings synced from Visual Studio Code on my machine to my GitHub code space. And I do that down here through my profile, and it syncs my settings across. But when we work with developers on projects that are code specific, we need them to have certain extensions installed to help and make their lives a little bit better. So in this devcontainer.json file, I've also synced, I've done a few things actually. It's declared the extensions we want our developers to have. So this is really important. We need these tools to develop this Java code. So you could do things like, we have Java tests in here, a decompiler, things even like Copilot, but also tools that are maybe going to be useful for environments, linting tools, testing tools, etc. These are all the tools we want our developers to have, no matter what machine they're working on, what environment they're working on. That's super critical. But I can also bring my own extensions over. So if you notice, Michelle, this is pretty much VS Code in the cloud, except in a kind of a more secure environment. So I can go down here to my profile, and I've actually synced all of my settings across. So I have these extensions that the dev container needs to build, but I also can bring my own. So I can bring my own color tools, my own tools that I know and love. So I have my own development environment. So we're no way limiting that developer. We can also do a few other things around settings that we need, any kind of post command. So this is compiling MVN, but a lot of times we can run a bash or PowerShell script afterwards. And when we spun up that code space, we saw that we required a certain amount of CPU. This is the minimum amount of requirements. And we did that because we know our code base takes that kind of compute to just run. So Michelle, earlier you also spoke about context switching. So when I switch context, I struggle. I don't know if it's my age these days or whatever, or just the limited amount of time I have to write code. So I have actually built my settings into the code space how I want them. So I told you I synced my settings across, but we have a couple things that we can play with. We have things like GitHub Copilot chat. I can pull that up in the corner, but also things like maybe Docker. If I'm doing any kind of development with Docker, I can see the images, the containers I'm working with. You can also connect to a registry. I often work with like Azure Container Registry, so I can actually see my registry from the context of my IDE. Couple of things, if you're working in Azure, you can connect to your Azure subscriptions. You can see the resources that are in your subscription. Now, I haven't signed into my Azure subscription this very moment because this is a brand new code space and a brand new repository, but I can see all of these things, which is really helpful. One of my favorite extensions, though, that I want to show you, other than GitHub Copilot, is GitHub Actions. So everything in this repository that we've spun up is automated. So I told you about code scanning that we're running. We build, test, and publish our code. Whenever we start the repository, we have an action that does something. We deploy our environment to Azure, but also things like we have a container vulnerability, and we've run a scan on all of our code, and we can see here that we have a red. I can click on this, I can get more details, and this will open it up in my GitHub repository. Now, what's really cool about this is I don't have to leave the context of my browser, and it's still secure, and I have access to all the tools I want. So if I go back to that code space, give me just a second as that's there. Okay. I have a full view of everything that's going on. Now, the other thing we use in our environments in GitHub are something called environments. So we have a production environment. We can set up a dev test, a QA environment here. But Michelle, this one's for you. Secrets. So instead of putting our secrets in our code, we can create a new repository secret. All right, Michelle, so we have a place to put your secrets in your repository secrets here. You can't actually see the secret. You can just see the variable that you need to put into your code. So I'll give you a really good example. When we go to build our code and deploy it into Azure, I will pull up a workflow file for you. So in our workflow file, when we're going to Azure, we need to potentially log into Azure as one of the tasks, authenticate into Docker, etc. So we don't put any of the secrets in our code anymore. So instead of Michelle putting your secret in your code, so where I need to put this password into our Docker login, it would go into that secrets down here that I can see down here. So I could create a net new secret, and then we could call it, whatever we need to call it, then call it in our code. So we don't actually need to display our secrets to our developers, which is really important. We don't expose that. We've lowered our attack service. So we have seen this ability in GitHub code spaces here to see our different environments, to see our secrets. We can put in our variables in here. We can see all the workflow files that we have. We literally automate everything we possibly can in a repository here at GitHub. It takes out the human error, and it doesn't take away your job. It just means you have less you have to do. Those less, we have dependency reviews, container vulnerabilities, code scanning. We want to clean up our environments because sometimes the world is a bit of a messy place. So those are kind of my favorite extensions in the GitHub code space. But let's look at another way we can help developers, Michelle, with a pull request. Now I'm going to put you on the spot again. When you open up a pull request, how much detail do you like to put into it?
Well, that depends. If I am opening up a pull request and it's just me, or maybe me and like a really close teammate, I'm not putting that much detail in there. But if I'm putting it into a repo that I know strangers are going to review it, or worse, people who I want to impress, then in fact, I probably would go a little bit deeper in there.
Okay, you say probably. I think there's a really good stat that like 50% of pull requests have like very little detail there. And we've all done it. So I've actually pre-created a pull request for us where I did make some changes to a file earlier. And often I'm rushing to get a feature in and I'm just impatient. And I do expect someone to have a crystal ball, read my mind, read the files, and know exactly what I committed. So, it's very easy. They can see the commit here. They're like, okay, I made a commit. They can track it. They can view the commit details. They can go and see the diff and see the files that were changed. They can do the review from here. They can see the files I changed here and like all these great changes. However, that takes time. And not only that, we're all lacking time and we're all trying to switch context. So I want to show you about a cool new feature with GitHub Copilot. So instead of saying I did a thing, we're going to go ahead and take that out. And we can see that I have GitHub Copilot here in my pull request capability. And I'll go ahead and make this a little bit bigger. So if I click on my pull request, my GitHub Copilot for pull requests, I can generate a summary. So GitHub Copilot is going to go ahead and generate a summary for our pull request. And what it's going to do, it's using the context of our pull request, meaning it's looking at our commits and the files that we changed. So it's reading those 4 files that I changed, and it's going to summarize those changes.
Is that in GA now?
By the time this gets released, it will be, yes.
I was looking for this. I'd heard about it. I think maybe I heard you talk about it, or it might have been Damien or Mish. And I was really excited about this one because, yes, I'm lazy. Everyone's lazy. And I know that Copilot is not lazy. It's really, really good. I trust it. And so, yeah, I was looking for this the other day, but I didn't look there. So, yeah, I'm going to check to see whether I have access yet because I'm super excited about that one.
It is one of my favorites, and I use it almost every day. Now, I get to cheat because I work for GitHub, so we get access to all these cool features in beta. It is going GA, but it's also part of a new licensing thing, of course, because we have to license everything. It's under GitHub Copilot Enterprise. So we've added more features in the browser around Copilot, et cetera. But more importantly, this has taken our pull request. It's taken the files that we've submitted. It tells you which ones they are. And it's summarized what our changes were. It also gives us the file there. So in this case, I changed some Python code and it goes to those. I can literally open up these files. I can see them, but it summarizes it. So you as the reviewer can go, oh, wow, April's done these things. These are the files she's changed, and I could see it. It's so much easier than the old way of doing a pull request. And then I also run some checks on my branch, and then I can go ahead and merge that pull request and we're good to go. It saves me so much time as a developer that this is written for me. And I know that my fellow colleagues or anyone out in the community does not have a crystal ball and they can't read my mind what I was intending to do on my pull request. So This is a great way to summarize what I've done, saves me a ton of time. And so they can see I've made some code improvements. They've seen I can do some testing, and that's really important. And again, it enables traceability, it enables communication and collaboration, and it's improved the way the developer experience has transpired over time. So everything I've shown you today is here to make our lives easier, safer, more secure, and to be better performing DevOps peoples out in the world.
I think that is amazing, April. Thanks so much for doing such a really useful demo. I've learned a lot of things and I obsessively watch everything you put out. I should say that April is my tech celebrity crush. She is like a god to me. Yeah, but new things for me today in there as well. That's, yeah, fantastic. Thank you so much for coming on the episode and joining us today. April and I are going to hang around for the next 10-15 minutes to answer your questions online. So if anyone has any questions, do put them in the chat now so that April and I can answer them. I want to remind you that you can check out any new Breakpoint episodes that you have missed on the Microsoft ANZ YouTube channel. You can also find all resources for the episode on GitHub. If you go to aka.ms/new-breakpoint/blog, you will find all the resources there. Thanks again for tuning in, and we hope to see you next month.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can. You'll also find a resources widget in the bottom middle of your screen. We've put additional links in there to learn more about what we've covered today. Lastly, tell us how you found this experience through the survey widget. If you're not staying for the Q&A, thank you for attending and we hope to see you again soon. We hope you enjoyed this digital event. Thank you for attending, and we hope to see you again soon.